Okay, for what we have in the remaining operation, and this will not be the usual addition, subtraction, multiplication, or division. What we will have this time is what is referred to as the composition of functions. And we have at least what is in the textbook. We have a couple of compositions that are introduced. Okay, and the first one that is usually presented is where we have f in front of the g, and so we have for two functions, f of x and g of x. If you notice, we have a circle that separates f from the g, and that circle does not refer to multiplication. Instead, it refers to composition. And now we have for the terminology, we have f composed with g of x, and this is what we have symbolically. So we have f composed with g of x is equal to f of g of x. And here, g of x is the input function, and f of x is going to be the output function, where its value or expression would be dependent upon g of x. And we will have the roles reversed, where we have in changing up the sequence. Now here we have for the next layout, we have g composed with f of x, and this is equal to g of f of x, where f of x is the input and g of x is going to be, or in this case, g of f of x is going to be the output. Now, in the case of looking at the composition of functions, say we have in looking at both f composed with g of x as well as g composed with f of x, say we have given that f of x is equal to 2x and we have g of x is equal to x plus 12. So f of x is going to be the output, g of x is going to be the input. So we have for f composed with g of x, if I take f of g of x, I'm going to have f of and g of x. Okay, that is at x plus 12. And if we follow through, okay, now we have f of the input, where we have x plus 12. Now again, we have the output function in accordance with f of x. So we have f of x is equal to 2x. And in terms of how to follow through with the composition, so you have f of the input is equal to 2 times the input. And with the input, g of x equal to x plus 12, now placed as the input, we have f of the input, again, is equal to 2 times the input. So in this case, we're going to have 2 times the quantity of x plus 12. So we have f composed with g of x has a final result of 2x plus 24. Now, if I reverse the order and I'm looking for g composed with f of x, so we have g of f of x. Now we have f of x, 2x, is now going to be the input. And in terms of the follow-through, now we have g is going to be the output function. Now we have the follow-through will be in the manner of g of the input is equal to the input plus 12. Now for the composition, okay, now the input we now have at 2x, and for the input plus 12 we have for the composition, whereupon we have g composed with f of x, we end up with 2x plus 12. All right, now let's say that if I have another set of functions, this time where we have f of x is equal to the square root of x minus 5, and g of x is equal to x squared plus 3. Okay, so if I have f composed with g of x, so we have f of g of x, and the input function g of x is now at x squared plus 3. And we're going to operate in accordance with f of x in the follow-through. Okay, so we have f of the input is equal to the square root of the input minus 5. Okay, and so for what we have here, the input is now at x squared plus 3. And so for what we have in this particular case, we're going to have the input, so we have x squared plus 3 minus 5. And so for what we have for the result here, we have the square root of x squared, and then plus 3 minus 5 becomes x squared minus 2. So the composition, f composed with g of x, becomes the square root of x minus 2. Now for g composed with f of x, now the input, we are now going to have the square root of x minus 5. and this is in reference to f of x being situated as the input function. And we're going to follow through in line with what we have for the output being g of x equal to x squared plus 3. And so for what we have later on, okay, so we have in this particular case, all right, so we have in this one, so you have g of x is equal to x squared plus 3. And so for what we're going to have now, okay, we have the square root of x minus 5 squared followed by the addition of 3, and the square root of x minus 5 to the second, I have x minus 5, and then followed by the addition of 3, okay, we have x minus 5 plus 3, so this will translate out to x minus 2. Now, in the crossover of looking at the domains of the composition of functions, and we have, in this one, we have for both f composed with g of x and g composed with f of x. Now we have the domain of the composition of functions will be formed by the values of x such that both input and output functions are real values. And say that if we're looking at the compositions and their domains, and let's say that we have f of x is equal to x plus 2 and g of x is equal to 4 over x minus 3. Okay, so we have in the setup, now we have for f composed with g of x. Okay, so we have with f composed with g of x. Okay, so we are looking at f of g of x and taking what we have now. Okay, so we're looking at f of g of x. So g of x we have at 4 over x minus 3. Okay. And then we have in the follow through we have in accordance with f of x is equal to x plus 2. All right. And now we have with input at 4 over x minus 3. Okay, it's going to follow that for what we're going to have in the outcome. We will have 4 over x minus 3, and we have followed by the addition of 2. And we will leave those terms separately. You don't have to worry about combining as a single ratio. Now we have for 4 over x minus 3. Okay, so we have for the input, okay, we have x minus 3 cannot be 0, so x cannot be equal to 3. And if you notice for the outputs, we don't have an even root radical, but we still have a fraction. And once again, so we have 4 over x minus 3, so we have the output cannot allow x to be at 3. So we have, so for keeping both the input and the output defined, okay, that is going to make up the domain of what we have in terms of the composition of f composed with g of x. And if I express, okay, what I have in the domain of f composed with g of x in terms of an interval notation, so I am leaving out 3. So I'm looking at the set of all values of x that will be less than 3, as well as those values of x that will be greater than 3. Now, if I reverse the order of the composition, okay, say if I have g composed with f of x, so you're going to have here, okay, so you have g of f of x, and now we have the input function is going to be x plus 2, so I'm looking at g of x plus 2, and now in the follow through, okay, so we are now looking at operating in accordance, okay, so we have with g of x equal to 4 over x minus 3. And in terms of following through, so we have g of the input is equal to 4 over the difference between the input and 3. So we have 4 over the input where we have x plus 2 minus 3. And if we combine the terms in the denominator, we come out to 4 over x minus 1. So this is going to be the resulting composition. And now looking at what we have laid out, okay, now for the input, this is a direct expression. So the input has no restrictions since we don't have an even root radical or a fraction that would result in a 0 denominator. However, in the output, the resulting composition where we have g composed of f of x, we have 4 over x minus 1. So we have for the output, okay, this does not allow x minus 1 to be 0. So we have left out from the domain, or left out of the domain, we have the x cannot be equal to 1. So we have combining the restrictions, none from the input, but we have that x cannot be equal to 1. So we have for the domain what we have for g composed with f of x. And it's going to turn out that we're going to have the set of all real values excluding 1. And if we take what we have on display in interval notation, so I'm going from -infinity, approaching but not including 1, and then representing the values of x greater than 1, we have parentheses around 1, and we have approaching infinity.